So we're going to actually work on giving you a method today of factoring quadratic trinomials, not through guessing and checking, but what I like to refer to as the unfoil method. So starting out with the unfoil method, let's talk about actually what foiling would involve again. So this idea of we have a binomial times a binomial, and if we are to multiply x times all components of the second parentheses and the -8 by all components of the second parentheses, we end up distributing and we end up with these four terms. To finish off the problem, again, we combine, we've seen this before, we combine these like terms. So the idea is that we know how to FOIL. What we'd like to do is take a similar type of process and work our way backwards. So we know how to go from parentheses out. We want to go from out of the parentheses back into the factored form. So reminder, this is called your factored form. So we're talking about factored. We're trying to get back to what multiplies to give me this polynomial. So what I did was, if you look at the two slides here, I have this is the way to go through foiling. This is kind of just going backwards. So I have the same original, here's your original problem on the previous slide, and here was your answer. What I want to do is kind of be able to work my way in the opposite direction. So I'm actually going to ignore, or I'm going to actually start working from the bottom here. And what I want you to see is, okay, if we start at this point, and these are the same three steps I had before, how can I move from the second line here down to the third line? Well, we've already actually seen this. When we have four terms here, how can we factor? We can take out the GCF, which in this case is x. We can group them and take out the GCF. The second group, the GCF, would be -8, and we're left with 2x minus 3. So you can see our one parentheses is 2x minus 3, and our other parentheses is x minus 8. The question really is, how do we move? So we know how to factor from this point, but we need to figure out how do we make the jump from the first line to the second line. So if you notice in the first line, 2x squared minus 19x plus 24, what's the same and what's different in the next line? Well, 2x squared stays the same. 24 stays the same. The difference is negative 19x. Instead of negative 19x now, we have negative 3x and we have negative 16x. Now, there's where your big question mark becomes. How do I get that value? So negative 3x minus 19x is still negative 19x. That's still the same value. But how did I know to make it negative 3x and negative 16x? Why didn't I make it negative 2x and negative 17x? Why didn't I make it 3x and negative 22x? Why didn't I make it some other combination? I mean, they're still equal, but why didn't I make it a different combination of values? The reason being is that we want to have this factoring by grouping, to be possible. And the only way it's possible is to select the exact right numbers. So how do we know what those right numbers are? Sorry, I had some technical difficulties there. We have to use, one of the ways we can do it is by figuring out using the unfoil method. So our goal is, keep in mind, we're trying to go from this polynomial to one with four terms so that we can factor by grouping. Okay, so if we look at steps here, number one, we want to make sure our trinomial is written in standard form. Number two, we're going to take the first and last terms and multiply them. So in standard form, when we write a polynomial in standard form, it's ax squared plus bx plus c. So what we're really doing is taking that ax squared term and multiplying it by c. And so in this case, we're going to take 3x squared and we're going to multiply it by positive 8, giving us 24x squared. Okay, the reason we're doing that is because, and I told you guys to keep this in mind because it would come back to you, and relate to this factoring eventually, is we are going to use these two numbers, 24 and negative 14, to complete our diamond puzzle. So what we're trying to make here is we're trying to figure out, to get those numbers that we're going to split this term into, we're going to split our middle term, negative 14, into, we're going to use 24, what multiplies to be 24, and adds to be negative 14. So we want to take those numbers, whatever those are, and here's negative 14x, and we want to split negative 14x into those two numbers. So multiplies to be 24, adds to be negative 14. We know they both have to be negative because we're talking about 24. And so the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So which ones are we using? Be negative 2 and negative 12. So we're going to use those numbers. Remember we said 3x squared stays the same, and 8 stays the same, plus 8. We're going to take those two numbers and we're going to divide, we're going to split, not divide, split negative 14x into negative 2x and negative 12x. Now, did I change the actual value of the equation? The answer is no. I'm just finding that kind of intermediate step of foiling so that now I can complete my unfoil. So break it into 4 terms, and then we can factor out an x, so we get 3x minus 2. We can factor out negative 4, so we end up with 3x and minus 2. And then our answer is 3x minus 2 times quantity of x minus 4. Quantity of 3x minus 2 times the quantity of x minus 4. So this unfoiling method, and I would definitely have the steps written down so that you can practice them, is a strategy to help you figure out what are those two middle terms I need in order to factor by grouping effectively. So we're going to have a few for you to try on your own. So pause this, go through the steps that you have written down, and try this one on your own. So pause, try it. Here we are. Step 1, you need to make sure your polynomial is written in standard form, which it is, second power, first power, no variable at all. Next step will be to figure out, to set up this cross puzzle here. And actually what I'm going to do is I'm going to write this above because I think it'll be a little bit clearer what's going on if you do the first term times the last term up above. So we're going to do 60x squared here. 6x squared times 10 is 60x squared. So we're multiplying to get 60 and adding to be 19. So we're trying to figure out, so 6x squared is going to come along, 10 is going to come along, and we want to figure out what does 19x become. So factors of 60, 1 and 60, 2 and 30, and once you find the right pair, I would go ahead and stop. 3 and 20, 4 and 15, and I could keep going, 5 and 12, but 4 and 15, positive 4 times positive 15 is going to be 60, and also add to be 19. When I write these in, plus 4x plus 15x, I would stop and look and make sure that your first line and your second line are actually 100% equal to each other. At times, if you choose the wrong factors, it'll be very obvious because it will not continue to factor. But if you choose the wrong factors, you may just be answering to a completely different question, not to the one that you're actually trying to factor. If I choose 2 and 30, even though, if I choose 2 and 30 here, it's not that this isn't going to factor, but I'm working on a completely different problem because 6x squared plus 2x plus 30x plus 10 does not equal this problem I started out with. This is 6x squared plus 32x plus 10 that I'm factoring. So you want to make sure that you've got the equality from your first line to your second line. So we don't want to include that. So if I continue here, factor by grouping, my first GCF is 2x, so I'm left with 3x plus 2. My second GCF is positive 5, so I'm left with 3x plus 2. So my factors are 3x plus 2 and 2x plus 5. All right, continuing on. Here's another one for you to try. So unfoil this. So this is 100x squared. So if we do our diamond puzzle, we're saying what multiplies to be 100 and adds to be negative 25. So if we're trying to multiply to be 100, we know we need to have the same signs, either both positive or both negative. If we're adding to be negative 25, we need both of those numbers to be negative. So for 100, 1 and 100, 2 and 50, oops, not 500, 50, 3 and nothing, that's even anyway, 4 and 25, 5 and 20, and I could keep going, but negative 5 and negative 20 give me negative 25. So x squared stays with us, 100 stays with us, and we have negative 5x and negative 20x. So we know what to break it into. GCF of x in our first group, so x minus 5 is the parentheses we hope to see in our second group. Our GCF in the second group, our first term is negative, so, oops, not negative 5. That's not the GCF, that's a CF. The GCF would be negative, biggest thing I could take out is negative 20. So I'm left with x and minus 5. And if you notice here, x minus 20 times x minus 5 is our answer. Notice here, those are the numbers we used initially to break apart our middle term there. They were the answers to our diamond puzzle. This will always happen, and you may want to note this for yourself. When a equals 1, so meaning, remember this is ax squared. When the coefficient on x squared is 1, the answers to the diamond puzzle will appear in your factors. So as you're doing problems like this, you may want to start thinking about patterns like this and maybe using shortcuts to help you get to answers. All right, we're going to try one more here, and this is the last one for today for you to do. So try this one. So we're looking for multiply these, and you got to be careful because 3x squared and negative 9, we have negative 27x squared. So multiplying to be negative 27, which means I need a negative and a positive, and adding to be negative 26. So multiples of 27 would be 1 and 27 up, and I've already got my first set here. 1 and 27 would be how I get negative 26. How do I get negative 26 out of that? Well, the 27 has to be the negative. The 1 has to be the positive. So keep 3x squared, split negative 27x plus, and I'm just going to put plus 1x, and minus 9 here. Order of those two factors does not matter. When I take out that GCF, 3x leaves me with an x squared and a minus 9. In the second set, 1x and minus 9. And your factors, realize if you put them in a different order, you may be getting slightly different versions of the same answer. But our GCF here is positive 1. That's all we can take out. So when we take out positive 1, we're still left with x minus 9. Regardless of the order of your factors, you should be ending up with the exact same factorization. Here is our factored form. Factored form. So quadratic trinomials are very important when it comes to our factoring. We're going to see these a lot. So we will continue practicing these for the rest of the week.